Good morning, everybody. My name is Karl Fischer. I am the CMO for DVT. I also have a role within DVT in the data and analytics space in terms of what we offer in services. And within that group, we have some very smart people like Mr. Jonah Kuria, who is our speaker today. In terms of what's going on lately in the market, there's an awful lot of noise around data science and what it can do and all the problems it can solve. So we thought it would be a great opportunity to have a session with Jonah, who can actually talk about it from a real data science point of view. I won't do the whole resume piece for Jonah. We thought it would be much more interesting for you to hear it directly from Jonah himself, as in that he is the resident genius for us, and hence why he is our data scientist of note and why he will be addressing you today. So welcome, everybody. And Jonah, thank you for making the time this morning to talk to everybody.
Thank you, Karl, for the introduction. Good morning, everyone. So my name is Jonah Kuria. I'm a consultant at DVT, concentrating on data science and software engineering. I will start by giving a short background of myself and the way I got into data science. So I am an academic, meaning that I do have a PhD in physics. I've always been fascinated by mathematics and science, and those were the subjects that I was actually very interested in when I was growing up, and then went on to do a Bachelor of Science in Physics. I took a detour to do some engineering in optoelectronics engineering for my master's, and then I ended up doing a PhD in physics. And physics in itself has given me a lot of opportunities because it combines a lot of different disciplines. You do a lot of mathematics, you also do things like electronics, you do some mechanics, and it gives you opportunity to have that a wide view of various disciplines. And another thing that it has also given me is the opportunity to work with data. Specifically, when I was doing my master's, I was to build an equipment which is to analyze optical lenses. And in that, I'm also dealing with data. And I was able also to come up with software to drive the equipment. So that's how I got into programming. And I was using a language called MATLAB. And then after that, I got interested more to look what other languages are out there. Then I moved on to doing things like C, C++, and then continued teaching myself, including web development, and picked up other skills along the way. So that's how I got into software programming. And then when I was doing my PhD, I continued working on analyzing data, specifically from waves. And using this data, I also created mathematical models where I'm also involved in doing programming to create these kind of models, specifically using languages like Fortran and C++. So that kind of keeps on improving my programming skills. And along the way, I also wanted to see how it would be like to work as a software engineer. And an opportunity presented in itself in the form of a company called ThoughtWorks, which set up shop in South Africa in early 2012. And I was one of the first few hires that they got. And that's how I got into software engineering. And I've been doing software engineering since then.
Jeepers, Jonah, you've shattered my dreams of becoming a data scientist. I saw this online thing that said I could master data science within like 1 month. I was going to sign up for that. Now it sounds like there's an awful lot that I've got to do.
Well, that is easier said than done, because when you look at a data scientist, it is not just one skill. It's not just about going to online tutorials and claiming to be a data scientist. It is a multidisciplinary and a multi-skilled type of role. So as a data scientist, from my personal experience, I had that background of mathematics and statistics coming from my education as a physicist, and also research So research also helps you to kind of look at data, that curiosity, wanting to see, if I change these parameters, what am I going to get if I'm working on a particular mathematical model? And if I change these parameters, what does the final result mean to me? So that kind of curiosity is needed for a data scientist. The other one is programming, which I have given a short background of how I got into software programming or software engineering. Then the other one is, how do I interpret these results? And that I also could say that I also gained a lot as an academic, because I have to explain to fellow scientists, why does this model work? Why does it not work? Why? I have to convince them, and also using visuals, because they say that you know, a picture will speak more than words. So you will kind of need to be intentional about visualizing your results, explaining to even non-technical people. So that one I also gained a lot as a researcher or as a scientist. And then the other thing is,
and I think in our conversations, the thing that we've come to that helped me certainly was understanding what it was that's really meant by data science. Yeah. So all too often folks have kind of meant BI, and they've repackaged BI as data science, but that's not really the case in terms of what you mean by data science, is it?
Yeah. So when I look at the definition of a data scientist, I see it as something which is multidisciplinary, something which brings these all skills together. Like it is an intersection of maybe business acumen, or maybe having an understanding of business. It also brings the computer skills like programming, knowledge of databases. It also brings the skills of mathematics, statistics, things like linear algebra, things like calculus, so that you can have a good understanding of what you're trying to do with models. Because the most important thing that a data scientist will do is to look at that data and think scientifically, hence the name data science. So it is a science as well as an art. So that's why you're going to be intentional about explaining your results in a way that everyone can understand. So hence the visualization, the storytelling. You need to convince people. You need to help them to understand what they cannot just look at data, because you are the scientist and you're the one who is going to look at the distribution of the data and say, because my data is, for example, a binomial distribution, I'm not going to try all the methods in the world. I'm going to try A, B, C, D because of what I can see from a scientific point of view. And that is very important. And these are things that you will need to take a lot of time to get into. Yes, it is possible to go online and do some courses, but getting to that particular point where you say, now I can think about this data scientifically, I can discover the patterns and explain scientifically, and from there go on building the models and you know, making an impact in business. It is a journey, it takes time, but there is hope, because there are all these resources out there, but you will need to take your time to get to that particular point where you say, I can now sit down and do the art and the science of data science.
Well, speaking of visualizations, it would be great if you had a slide to show us what you mean by data science, yeah?
Okay, let's get right into it. So in this section, I'm going to define data science, and I'm also going to kind of get into the role of a data scientist by looking at the data science life cycle. So these are some of the things that I was trying to explain. You can see that kind of intersection there. We do have the skills that a data scientist brings in. It is also a team sport. A data scientist cannot give you the results that you need on his own. He will need to work in a team. And I think I will come and explain this at a later section, how you can build your team to make sure that you're getting the best out of your data. And then you will have the data scientist, one of the most important skills that a data scientist have is the quantitative or the mathematical skills, and also the data analysis. So before you become a data scientist, you first of all need to be a data analyst. You need to know what to do with the data. You need to see the patterns without, first of all, going into building the models. One of the things that I have seen in my experience is that a lot of people are fascinated by machine learning. They want to go right into it and build models. Unfortunately, that does not work in the real world. Most of the time you will work with data. For example, most of the data scientists have said that 70% of their time is spent looking at the data, and only 30 or less percentage of their time is spent building the models. And I think many people being fascinated by building the models, I think you can, first of all, take time, know the data well, and see how you can, first of all, get the basic analytics. So that's a very important skill. The other skill is the business or the domain expertise. So if you're an academic like me, you will definitely not have that chance of being a domain expert. But one thing that I have learned over the years is when you're working with business, you need to have that curiosity. You need to keep on asking the right questions. And this is also another skill that you develop. You don't kind of ask the right questions just like that. It takes time, and you still need to keep on asking the right questions to the business, learn about the business, and this is where you develop your domain expertise. The other one is the computer science or the traditional software engineering or software development. You can start with some of the common languages that are out there today for the data scientists. The two top of them are Python and R. They are not complicated to learn. One thing from my experience, because I have worked as a software engineer, I have seen that once you master a language, it will be very easy for you to go to another language, because you will be thinking, this is the way. For example, if I take the languages that I started with, C and C++, you will start thinking, this is the way I do assign my variables. This is the way I create my functions. For example, in C++, this is the way I create my classes. And then you will bring on this knowledge to learning a new language. So having one language that you are an expert at will help you to kind of pick up other languages along the way. And then the other thing is the visualization. So Python and R, they come with a way that you can visualize your data. An important thing is, before you kind of present your findings to the business, you need first of all to work with that data in a process called exploratory data analysis. You need to create visuals to see how is my data distributed. And once you know how your data is distributed, for example, you will know the kind of techniques that you will take to do, for example, your feature building, and also your data modeling or creating the models. So this is a very important skill, and closely connected to this is the storytelling. After you've created a model, will you just leave it like that, or will you be able to explain what you have found in the data? And the most important thing is that after now creating this particular story that you're going to take to the business, you need also to kind of guide the business into having actionable items from the insight that you have created from the data.
So Jonah, in your experience in working in organizations, it's different to software building in terms of the usual thing that would take place with someone that defines what it needs to be and says, well, this is what I want, and a team that functionally builds it. In your case, and in the data science space, it sounds very much more like a direct engagement and backwards and forwards between the business side of the world and then the technical delivery skills that sits in data science, data wrangling, and others. Is that right?
Yeah, that's correct. If I can draw from my experience as a software engineer, you will get the requirements saying that, for example, if I'm building a backend service, I want to be able to call the service, maybe to give me a list of customers, I need to update the something when they interact with the service. So it's a predefined task that you will do as a software engineer. On the contrary, the data, the business sometimes are not sure what they want to do with the data. And this is where you bring in your expertise. You sit with the business, look at the data, and find out the data that they have. And from these, engage with them and see what do they want to do. And then you will be able to advise them, is this possible, or should we also try another thing? Because the business might be having this idea, but you are the expert who is looking at that data, and you need to advise them on the correct way to utilize that data to get insights that will improve their business.
So software engineering's learned from the mistakes of the past, and they've gone more with the agile philosophy now and utilizing Scrum. Is that a kind of methodology that works in the data science field as well?
I would say yes and no. The yes is that you need to kind of have a way that you organize your team in a way that you will break down the task and have set goals. For example, you're running sprints like in 2 weeks' time, and then you need to, for example, come up with an MVP saying that to the business that within the next 8 weeks, I'm going to deliver this piece of work. The no comes in because unlike software engineering where you have predefined tasks, sometimes it's going to be defined by the data that you have. And some of the things that will set you back is, for example, the data is not clean, you're getting the data in real time, so you will need a way to kind of have a differentiator between the traditional software engineering and data science, knowing that you cannot have sometimes those hard deadlines. It will depend solely on the data. The data will be your guide. That's why we talk about data-driven organizations.
Okay, and in terms of a process that typically describes how the data science engagement works, is there something you can take us through for that?
Yes, so on the next screen, so I'm going to also draw at this point, this is a typical data science life cycle. So it is not cast in stone, but basically this is sort of a blueprint where most people follow this kind of blueprint. And I'm also going to draw from my experience. For example, I have worked in the financial services industry where you're getting data from the online channels. So the first step is you will sit down with a particular section of the business who are the owner of this particular project. And once you sit down with them, you will be advised on the data that they do have. And in this case, for example, in my case, it was data that is coming from online channels, which includes the logs, the transactions that are happening, and such kind of similar data. Once you see it, you will need to know the goals that the business has. And once now they give you access to the data, because then there needs to be some policies in place on the data. We are living in the age where privacy is a great problem, or it's a great concern. So you will need to know what can you access, especially when you're talking about online data. What are you supposed to see, or what are you not supposed to see? And they are data stewards in these companies where they kind of give you access to the data that you do require. And you will also be involved in saying, maybe this data is not enough, or this is enough. This is all that I need to go forward. The next step would be, you now have access to the data. In this case, I get the online data, and then I do some gathering of the data. Maybe I'm getting the data, for example, from a SQL server, or maybe from Hadoop, and then I need to get it into my local environment. The next step after getting that data is cleaning the data. If, for example, I look at the log data I get from online channels, sometimes it's messy data. It is unstructured. So I need to create structure from this unstructured, and I will apply techniques such as regular expressions and other techniques that will help me to mine the data or to get the kind of data that I need to create a particular structure. Because you cannot, when you are targeting to work with models or to do data analysis, the messy data will not help you. So you will spend a lot of time doing the cleaning of the data. Sometimes we call it data wrangling. You will find in some cases you have missing data. So you will need to come up with an idea. Am I going to drop this data, or am I going to impute the data so that I will be able to work with this particular type of data? Now, when I am past that stage where now I have the data, I have talked about to the business, I understand what they are trying to do, I will go to a process where I need to convince myself as a data scientist by doing data exploration. In this stage, we call it EDA, or exploratory data analysis. This is where I look at the data, the columns in the data, are there any missing columns? I do some visualization. For example, I will do some bar graphs. I will need to put the data into percentiles. For example, what can I say about the 25% percentile, the mean, the median? All these kind of basic statistics will come into this stage of data exploration. And then once I'm done with that, I am convinced that now I already have an idea of the technique that I'm going to use. The next stage is doing what we call feature engineering. So in feature engineering, I will give you an example. Let's say, for example, you have a business where you are selling houses. Some of the features that you might want to have in that kind of business, I want to know the number of rooms, how old the house is. So this will be the features that you will need. For example, if you're going to do to predict the housing prices. And then the next stage will be, I have done all this, I've cleaned my data, I have the features, and then now I have decided the kind of models that I want to do. Are they going to be predictive models? Am I going to do classification of the data? And this is where I now do the modeling. And as you can see, along that stage up to this particular point where I am doing the modeling, I have done a lot of work with the data. I have interacted with the business. So this is just a small percentage, as you can see. And once I have built the models, I will now do some visualization. You can do visualizations using the tools available to you, for example, in the Python ecosystem or R ecosystem. And then you can also go higher notch by building, more appealing visualizations using tools like Tableau, Power BI, ClickView, and so on and so forth. And then these visualizations will help you to create a story, to go back to the business and say, these are the patterns that I have found in the data. And I am seeing a region of interest because I'm seeing your customers in a certain region, they are not interacting with your channels as they are supposed to do. And then that will help kind of create that actionable insight. And basically, in a nutshell, this is the way I would interact, or the way I have interacted with business from the time I sit down with business until the time that I do the data visualization or I present my results to the business. Another last important stage, you can see the last bullet point is start there, is deployment. So when you're working with the Python tools or R tools or whichever system that you're doing to do your models, it is not complete until you do some deployment. Sometimes you will need to give a client something, a tool they can work with. Sometimes you will need to integrate with an existing system. For example, if you're building a recommender system, by just doing it on your own local machine will not be enough until you integrate with an existing online portal or such a system. And this will require more skills. In some cases, a data scientist will not be able to do this, but if it is a data scientist who also have software engineering skills, he will be in a position to do the deployment. And in some cases, you will have people with specialized skills called machine learning engineers who do have some knowledge in data science and knowledge in software engineering. They will do this kind of deployment.
So Jonah, as always with this, once you talk to somebody that's actually involved in this kind of work, you you clearly get a better appreciation for just how complex it can be and the high dependency in terms of working with other people. So in this case, and through a process like this, what does a team look like? What's the structure of that team?
I will move on to the next slide and talk about the team. So the constitution of the team can be done as you organize a software engineering team. You will, of course, have the data scientists. You will have data engineers. So the data engineers are the people who will work with the data, create your data pipelines, do the ETL, and help you in getting the data that you will be working with. As I have mentioned previously, you can also have machine learning engineers. This is not a must. You might have what we call full stack data scientists. So these are people who have all these kind of skills. They do have software engineering skills. They can do the deployment of your models. But in case it is not a must for your data scientists to have all those kind of skills. The most critical skills that a data scientist should have is thinking scientifically and taking that data and helping you to get the insights to build the models. And once they have done that, you will have the machine learning engineers who can now create systems to integrate with existing systems, or they can create new systems to deploy the models that are being created by data scientists. Another constitution of the team that you can have is cloud engineers. So we are now living in an age where we are leveraging cloud solutions, because sometimes the infrastructure that you have on premise maybe is not enough, or it has limitations. So you might also need cloud engineers who will help you to deploy these models onto the cloud. And then you can also have somebody like a product owner. So this is a person who will act as a go-between the team and the business. It could also be somebody, you could also have a scrum master who could also help you to kind of organize the team stand-ups, do division of the tasks that the team will be having. And you can basically kind of constitute the team the way you would constitute a software engineering team. But basically, this is just from my experience, one of the ways that you could build up your team.
Great. And then in terms of how that team would then function and the sort of the how of their operation, what would that look like?
So once you do have the team, you will need to come up with a strategy. You will need to have the way the team will work together. So, for example, you will need a continuous feedback loop between the team and the business. So you will need to have an interpretation of what the business needs, because sometimes the business might have these high-level ideas they want implemented, but when it comes to implementing them, you will need sort of kind of a business analysis to do the interpretation of the requirements of the business. Then you will have your data engineers who will help you with the data infrastructure. And then once you do that, you will come together with the data scientists who will get that data and work on the data, doing the analysis, getting the insights. Sometimes it will not end up in a model, it will end up on an analysis of the data and patterns that you have realized in the data. And then once you do that, if they are models, then you will have a way of deploying those models using the skills of the machine learning engineers. And then you can also deploy these models or the insights that you've got to the cloud using the skills of the cloud engineers.
All right, John, I think if you just drop through to that slide again that you were showing the process on, I think that's a useful one to just step through and kind of go, well, if that's the standard process in terms of how you've worked through projects, along the way, what are the things that are really the big challenges to engagements and the process that you follow?
So maybe I can just first of all talk about the way you can organize your process. You need to first of all come up with a strategy. If you're getting started, you need to have a plan, and then you can identify the particular areas. You can do some research. Is it marketing? Is it the product that you want to improve? Is it the customer service? And once you kind of identify these areas, you need to have the data that is targeting or that is backing up the area that you want to go with. Let's say, for example, you want to improve the customer service. You kind of need to get this kind of data. Are you getting it from the call centers? Are you doing some customer reviews? Are you looking at your social media platforms? And once you have targeted this kind of data, you will do the collecting of that particular data in a way that it can be used. And then you will go on to do the analysis of the data. And once you do the analysis of the data, this is where you do all these, the data science life cycle that I talked in a previous slide, where you go do the analysis, you do the building of the models, the cleaning and all that. And once you do that, you will come with the insights. The most important thing after the insights is you need to sit with the business and talk about the insights that you have gathered from the data. And then if the most important thing or the step forward will be sitting with the business and seeing the actions that are going to be taken from those particular insights.
And the challenges that you've seen that have come up during the process, what's made it difficult or thrown a roadblock in the way of actually moving ahead?
So one of the challenges that I have experienced is sometimes there is no clear target set by the business. And the data is there. They do have a vague idea of what to do, but you will need to now look at the data, bring in your expertise, and bring up some suggestions with the business to see how you can work with this particular data. So when you don't have those type of requirements coming from the business, it will depend a lot on you looking at the data and giving suggestions on how this can be done. The other challenge that I have seen is that, like I mentioned before, there is the comparison between data science projects and software engineering. You will kind of find the business saying that we are, for example, having the team that is building our online channels, and they are doing this in a particular way, in a particular time. They will also expect you as a data science team to do the same kind of work or the same steps followed by the software engineering teams. This is a challenge because you don't have those particular goals set by the business upfront, and you cannot run them exactly as software engineering teams. So this is something that you need to keep on talking about with the business so that you can draw the expectations so that you don't disappoint in the long run.
I guess that's where the value of the use cases comes in, is that you can kind of use those to talk to the business side of the world to go, this is what's possible, and these are the types of things that we can do, so that you can really start getting them to think of the questions that they might want to ask of their data, and the type of things that they could expect out of data science. Is that where you typically start with some folks that perhaps don't have the exposure to data science? And you go, well, let me tell you what's possible?
Yes, exactly. So there are some common use cases which are generic that you can bring onto your organization because the most important thing is the data, and you do have the data. So you will kind of look at some common use cases that you can do with the data. And from there, you can come up with a combination of other use cases or new use cases after you have done some of the common use cases.
Okay, well, that's probably a really good point for us to take a look at some use cases, yeah?
So let's dive right into it. So one of the common use cases, because in most businesses, you are dealing with customers. You might want to group those customers into groups depending, for example, on the demographics. You can do that on psychographics. You can do that on the behavior of the customers. And you can also do that on based on geographical regions or geographical factors that are affecting your customers. So once you have your customer base, you already have the data, you do have your customers, you can decide to segment the customers so that you can have an idea of a particular group of customers. What are they doing? What are their needs? And these, as we will see later, will help you to kind of improve some of the processes, the services, and the products that you are working with. So one of the things that you can do is by segmenting your data, your customer data, into demographics. For example, you can look at the age, you can look at the gender, you can look at the income, you can look at the family status, you can look at the education, and you can also look at the ethnicity and such kind of things that falls under the demographics. Another thing that you can do is you can look at the geographical issues of your customers. You can, for example, look at the postal code of your customers, the city that your customers are based in, and see the differences between all these cities. In our case, in South Africa, you can look at the provinces. What can you say about the customers in Gauteng, the customers in Cape Town or Western Cape, in all these other provinces, in KwaZulu-Natal? You can find there are some differences based on these distributions according to the geographical regions. Another thing that you can look at is the climate. You might want to target, if, for example, the climate of a particular region is hot, you might want to target certain types of products or services. If it is an urban setting or a rural setting, you might also want to do some targeted marketing. The other one is the behavioral. In this case, you are looking at the way your customer interacts with your products. So you will find maybe a certain group is very tech savvy. For example, the young generation might also be interested in gamification of your products. Maybe the older generation, all they want to do is to do their transactions without worrying of all these bells and whistles. But maybe the younger generations will want to see all these fancy things, the gamification and all this kind of stuff. The other thing that you might want to look at is the psychographic. So this talks about the lifestyle, the interests and the activities. And that might also help you to kind of say, I'm going to target these people because these are their interests, this is their lifestyle, this is how they're spending their money. And because they're spending this, I have this particular product tailored for them.
That also suggests that you're looking at some very dynamic data sets in terms of what's coming in to influence those models. And I guess nowadays it's not just about segmenting at very high levels, but almost getting down to a marketing and advertising capability at the individual level. Is that what you're seeing is happening with the data?
Yes, so the important thing about the segmentation, you can drill down to the individual level, or you can say that I'm going to target this particular group of customers. So the more data that you have, the more it will help you to know, am I going to drill down to the groupings, or am I going to drill down to the individual level? And there is no reason that should hold you back from going down to the individual level, because nowadays we do have a lot of these data sources, as you have spoken. We do have, for example, the SMSs, we do have the online transactions, we do have social media platforms, so you can also do the targeting of individuals as well as the segments that you will target. So some of the benefits that you will get is to, for example, you will have a way of improving the customer service. You can also have a targeted product or improving your product and services. So a strategy that you can take when you're doing segmentation, you first of all need to engage with the stakeholders, because you might also have an idea yourself as a data scientist, this is the way I want to do, but the business might be having a different idea. So the most important thing that I have seen in this type of project is that continuous feedback between you and the business, because they will help, you will know what they require. And on the other hand, you are the one who is looking at the data. You will be able to say whether it can be done or it cannot be done, and whether you have different ideas that can help improve the original idea that the business has. When after engaging, you will come up with the objective, the scope, and the deliverables, and come up with a work plan. And this will include telling the business, I'm going to take this particular frame of time to do to come up with the segmentation. After getting the data, you will go to do the analysis. You have mentioned that the data is coming from multiple sources, which is true, and this will give you the structured and structured data. Sometimes you might have semi-structured data, which is sort of a combination of the two. It might have sort of a high-level structure, but when you look at it, it is not actually so structured. So you want to create structure from the unstructured and the semi-structured. After that, you will create the segments that you have agreed with the business based on the features that you have agreed. Are we going to look at the age? Are we going to look at the income brackets? Are we going to look at the psychographics or the demographics, and so on and so forth? The other step is you will now sit down and visualize to the business and say, these are the segments that we have created, and the business will get an opportunity to see whether the idea that they had, or they can see something, some opportunity they have missed in the past by just looking at the segments. And afterward, you can repeat this kind of process and come up with new segments based on the segments that you have created before.
Cool.
The benefits that you will get from doing this kind of segmentation, you will be focused on a certain segment or a certain section of the market. Instead of just treating all your customers in the same way, you will, for example, know the tech-savvy ones, I'm going to improve my online channels. The ones who want to just come on the mortar and brick offices, I want to make sure that they're served very well so that they keep on coming. And you might also want to have a high quality of revenues. And you will be concentrating on the right kind of segment. And you will also have an opportunity to improve your particular product or your particular service. And you will also have the opportunity to have those opportunities where most of your segment is bringing a lot of income to your business.
Great, Jonah. So apart from segmentation, is there another little example that we could step through on the use cases side? I'm just conscious that we want to keep some time for questions from the audience at the end of the session. So perhaps the next one we'll just skip through fairly quickly if we can.
Okay, so I will go quickly to some of the other generic use cases that you can take and make sure that they work for you as a business. One of the things that you can do is price optimization. So this is dependent on certain factors. You need to be aware of the history of your pricing. You need to look at your previous pricing options and the current ones. The season, sometimes prices change with seasons. For example, the winter season, there's some things that you will be selling more, they will be having more demand. You need also to be aware of your operational costs so that you can consider the cost that you're incurring to produce this particular product or service. Then the demand, you don't wanna do it the other way around or the opposite, where you do have a lot of demand, but you don't want to continue feeding that demand into the customers. You need to concentrate whether if you have a high demand, you need to make sure that there is that particular flow. And then the other thing you need to consider always is your competition. This particular product that you're selling, how are my competitors pricing this particular product? And once you put these factors in place, you will come up with a strategy where you gather this data, the transactional data, the data from your competitors, the customer reviews, what you have previously priced this particular product or service. And then after that, you will come with a goal. Do I need, for example, to come with some loyalty programs that I want to give my customers? And what are the legal implications of the goals that I put in place, for example, the loyalty programs? The other step will be looking at that particular data and generating the models. You can use generalized linear models which do your price optimization. Another thing you need to be very careful in this particular step, training the models once will not be enough because you're having changes. For example, we are all experiencing the turmoil that is brought by COVID-19. So it doesn't happen all the time, but such external factors that influence the market you will need to put this into consideration so that you keep on training and retraining your model, just so that to make sure that you keep on updating your optimization. And then the other step is to execute and adjust the prices accordingly. So do I need to, for example, lower the prices a little bit? Do I need to increase a little bit depending on the demand and the things that I have seen from the models? And then after that, you will have a feedback loop on whether is this working for me or is it not working. And you will also keep this in comparison with your competitors, of course, and also the ultimate goal is to make sure that you're getting something or you're getting the optimized price in the long run.
So Jonah, does that almost sounds like it fits with research methodology of sort of doing the A/B testing or small sample sets that you use to prove a hypothesis? Is that what you see happening in terms of the process when it's followed like this?
It is, and thank you for mentioning research in this case. One thing with data science is that it is research oriented. And that's one of the things that differentiates it from other IT projects, because sometimes it will take more time because you are creating these models, you're going back, you're looking whether it will work, you're adjusting certain parameters, and this is where the research comes in data science. And that is why you cannot always work as other IT projects when it comes to data science. So it is a continuous research, a continuous feedback with the business, and also continuous feedback with the team, seeing what you can improve. And sometimes you're also getting the data that you're getting, it starts becoming different because sometimes you're getting data in real time. And it will depend on the seasons, it will depend on the, for example, at the particular time of the month. For example, with online channels, you see a lot of transactions happening at the end of the month. So you need to be cognizant of all these changes that are happening to your data. So that's why you need to keep on researching and re-evaluating and improving your processes.
So not just smart systems, but smart people needed too, yeah?
Yes, yes. So that is actually needed. And that speaks also to the case where you do have these offerings which are promised to do automated machine learning and all that. In as much as these are good offerings in the market, you also need to have a way of having human intervention in these cases, because a human is the one who will know the external factors affecting the market, for example, and they will be able to do to have that particular input so that you can work with your models in a new way. Some of the benefits that you get from this price optimization: you have an opportunity to consider all the products. You have that competitive strategy because you are comparing pricing with your competitors, and then you can anticipate the trends. For example, what are the trends that happen in summer? What are the trends that happen in winter? What trends are happening, for example, when you have Black Friday? Such kind of things. They prepare you to have enough to offer to your customers, and also to have quality to offer to your customers depending on these trends. Another thing that has been that can be done based especially on the emergence and the increased use of social media and online channels is customer sentiment analysis. So you want to look at what are the customers saying about my product offering, my company, or the services that I am offering. And this will help you because when the customers are happy about your product, then that means business is good for you. And if they are complaining about something, you also have an opportunity to improve your offering. The data that will help you to do this is coming from social media. You do have your Twitter, Facebook, and the like. You can also do your customer reviews. Sometimes you can have online reviews. When I buy a certain product or I use a certain service, I want to know the review that the customer is leaving there so that I can have that continuous improvement. The call center, some people will call the call center when they have a problem, when they want to know how to use a certain product or service. This will give you an opportunity to know have I given enough to the customers in a way that they can use my product or service without struggling? The other one would be customer surveys. You can conduct online surveys, you can do questionnaires, and so on. And once you do have this kind of data, then you will be able to do some text analytics on the data and come up with the feedback that you're getting from your customers. And the metrics that you're looking in this case, you want to know whether they do have a positive or negative or neutral. And then once you do this, you will know whether to improve or to keep on offering that good service that your customers are happy about. One of the challenges that I have seen with text analytics is sometimes the customers give, some vague feedback. So you need to encourage your customers to give something that the data scientist can work with. Some of this, because you are using the machine to analyze this, when the text is too short, for example, if I give a one-word feedback, it doesn't mean a lot. But when I give, for example, a sentence saying that I am happy with a particular product because of A, B, C, D, and for example, mention the particular product and use the right adjectives and the right description of the product, that will help the team to do the natural language processing of the data so that I can analyze and say, this is positive, this is negative, or this is neutral.
Right. And I guess in terms of the new tech that's out there, like NLP, that would enable conversion of sort of audio engagements between customers and service desks, and then that data feeding into a data science program like that, that certainly gives you data streams with very interesting data to analyze and bring into this kind of thing.
Yeah, so it's an interesting space that we are in, where you can also do all these voice, you can do video, you can do all these kind of social media channels. And what you want to do is to make sure that you are in a position to understand exactly what is being said. We do have a way that you can convert your audio to text and all that. You need to have a clear way of making sure that you get data that is valuable for you to be able to know whether this is a positive sentiment or this is a negative or this is a neutral sentiment. And some of the benefits that you expect to have when you do this kind of work, you will be in a position to improve your customer service. And then by mining the data from all these channels, you can also have a competitive strategy by looking at what your competitors are doing. The other thing is you can improve your products or your services, and then you can reduce customer churn. So some people will start by complaining that you're not offering A, B, C, D. The next thing that you know is that they are no longer using your products or your services. But once you, for example, know the problems they are facing before they stop using your products or your services, you are in a position to address the needs or the dissatisfaction of your clients. So this is very important. And another thing that you can do with data is actually predicting customer churn, which is one of the other use cases that you can have. Awesome. So thank you very much. I think I will end it there unless there are questions regarding the presentation and the topic that we were dealing with.
Indeed. And Jonah, thank you for that overview. I think that's been very useful in terms of at least getting an appreciation for what a team looks like, how that team functions, and again, connecting it into what the use cases are that people need to consider. It's always something that we hear from enterprise customers about their initiatives in know your customer and understanding what your customers' experience with your products are, and getting that in combination with segmentations and looking for the business upside in terms of price optimization. You can see where the data science comes into this. So thank you for the time you've spent this morning. I would ask folks, please, if you have a question now for Jonah, why don't you just drop that through on the chat side of things. You'll find the chat icon at the bottom of your screen, probably in terms of the menu bar. Just plug that through and let's see if we can pose a couple of questions to Jonah. So we got one from Ronnie that is, in the team you're currently working in, what's the makeup of the team, Jonah, and how many people are in that team?
So in the current team that I'm working with, the makeup of the team, we do have a product owner or the lead who is interfacing with the business. We also do have data scientists, we do have machine learning engineers, and we do have a team that is taking care of the data, the big data team. We also have a combination of senior people and junior people. One of the most important things that I have seen by kind of having this kind of setup is you can pair the senior members of the team with the junior members of the team so that they can pick up the skills. And also for the data scientists who are not so familiar with software engineering practices, the software engineers in the team or the machine learning engineers with the team, they can pair and they can pick up the software engineering skills. And at the same time, the software engineers or the machine learning engineers want to bridge that gap into the data scientist world, they will also have a chance to pick up those skills. So kind of having this kind of combination of the team is a very good idea. And we are also working in an agile way where we have, for example, bi-weekly sprints. We also do work with 8-week MVPs. So we encourage as much as possible to use the agile methodology in our team. So basically the makeup of the team is your data engineers, you do have your machine learning engineers or software engineers, you have your data scientists, and then you have people who can interface with the business just to make sure that we are doing what the business requires.
Thanks, Jonah. So another question in here, in terms of what are the minimum requirements for someone that might be applying for a data science job? What would you say would make for a good profile and a good applicant in a data science job?
And that's an interesting question. So one of the things, because I've also had the opportunity to sit in interviews, one of the things that we are looking for, we need to see that you're curious. You need to know basic skills. You need to know basic frameworks that you're working with. For example, the data science frameworks. You need to know a programming language, which you can do some basic programming. And you are also, in a way that if I give you, for example, data, can you tell me, can you do some basic data cleaning? For example, if it is an entry-level position, can you make a basic model? Can you explain why you chose that particular model? And can you say, can you give me the thinking process that made you to choose that particular model? So basically you will need your programming skills, you will need your mathematical skills, and you will also need your visualization and your storytelling skills.
And I think, Jonah, that links into to answer Shailene's question more specifically. Is DVT hiring data scientists at the moment? The answer is yes, we're always looking for the right people to join DVT. I think for anybody that has an interest in the area, just be aware that the opportunities actually lie across the entire process. So for folks that are machine learning engineers that like working with dropping in data sets and getting the results back from the models, that's one dimension of it. There's the data wranglers that Jonah's mentioned as well, the folks that connect to source systems, clean the data, and get the data prepped for training in certain models. And then there's folks that are already in the data science space, the geniuses like Jonah that already understand the mathematics behind it and can look for data bias and can look at what the relevant models are that should be applied to the data given the questions that are being asked. So it's a wide range, and I think that's why we sometimes struggle in terms of people's definition of what a data scientist is, because really the data scientist is one member of a team that works in these engagements. And in some cases, you might start somewhere else and build your way up to the data science component. That makes it no less important or no less interesting in terms of the role that you might fulfill on a team like that. Any other questions? I know that everybody is at home, hopefully, staying safe and staying healthy, and that perhaps you can run 5 minutes over. If you do have any other questions or and we don't cover those today, then please do feel free to send those to us on email. More than happy to actually deal with that. There's probably a last question, and it comes to something I think we started with. Let's just deal with this one, Jonah, is the last one for today. The real difference between a BI developer and a data scientist, what differentiates them?
From my experience, I think the BI developer will be more concentrated on the data sources, working with that data from a SQL perspective, and maybe building dashboards using tools like Power BI, whereas the data scientist will concentrate more on the statistical nature of the data. That is the science part of the data, how the data is distributed, and also doing the models. So in most cases, you will not have your BI practitioner maybe going all the way to building these statistical and machine learning models, but the data scientist will do. So the data scientist in most cases will also not go so much into doing the data from an aspect of database point of view, getting all this data, creating all these tables and so on, but will be the consumer of the data that is coming from the data sources, and then applying the statistical methods and doing the visualizations which are based on statistics, and then building the models themselves.
Great. Thanks for the question, Aubrey. And to everybody that joined us today, thank you for joining our Insight session. Again, if you do have any further questions for us, do send that through. More than happy to get those answered for you. I hope you found it informative. I hope you'll join us on our next Insight session when that comes available online. Have a great day. Stay home, stay safe, and we'll see you online soon. Thank you. Thank you, Jonah.
Thank you, everyone, for your attention. And thank you, Karl.
Have a great day, everybody.